All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.3 in Algebra 2. This is the second video, and we're going to talk about the inverse of a 2 by 2 matrix, and then we're going to go ahead and dive into some cryptography stuff. So you're going to be expected to memorize this formula for an assessment. So let's say that you have some matrix A, right, that is that A, B, C, D 2 by 2 matrix that we've already seen. Then A inverse, right, the inverse of A, is 1 over the determinant of A times this matrix that we get when what we do is we switch the A and the D, so D and A switch places, and we change the sign on the B and the C, but don't relocate them, okay? So again, and just as a reminder, that determinant A is the same as AD minus BC, okay? And then what you do to the matrix is you switch the A and the D, right? So the A and the D are going to switch places, right? So it becomes D and A in the opposite places. And then you're going to change the signs but not relocate the B and the C, right? They're going to get a negative in front of them. So negative B and negative C. So let's go ahead and walk through that with our example 4. If the determinant were to be 0, because you cannot divide by 0, then you would just write no inverse, right? There's no inverse possible. So my A inverse here, right? So my A inverse. Now, before I bother to find that, I might want to go ahead and find the determinant of A and see if there's an inverse, right? The determinant of A should be AD, which would be 1, minus BC, which would be 3, so that's a negative 2. So my A inverse is going to be a 1 over the determinant, so 1 over negative 2, and then this is where we have to pay attention to the patterns here, right? I'm switching the A and the D. Well, I'm switching these two, but they're the same number anyway, so it doesn't matter. And then I'm changing the sign on these two, so this becomes a negative 1 and a negative 3 because they were both positive. The last thing I'm going to do is I'm going to go ahead and distribute that number in here and get that this is a negative 1/2, a positive 3/2, a positive 1/2, and a negative 1/2. And that is my A inverse. Okay, so that's how you calculate the inverse by hand. So let's go ahead and do the same thing for determinant of B. Before I even bother to find B inverse, right, I should probably start with what's the determinant of B in case it's 0. Well, that's going to be a 16 minus a 16, which is a 0. So there's no inverse, right, because I can't divide by 0, and that determinant goes on the bottom, okay? So we're going to go ahead and try a P4 the same way. So again, we're going to find the formula by hand, right? So I would suggest that a smart play is to start with what's the determinant. So the determinant of C would be AD, which is 4, right, minus BC, which is 3, so the determinant is 1. Well, that's about as friendly as a determinant can get, right, because that's going to be 1 over 1, which means I'm not going to have fractions that are crazy. I'm going to switch the A and the D, but again, in this case, they're the same number, so it doesn't really make a difference, right? And then I'm going to change the sign on the C and the B. And so when I distribute that 1 in there, it doesn't really do anything, and I get 2, negative 3, negative 1, 2. Right, that's my C inverse. All right, and when we do the same thing that we've been doing, but we do it with D, right? So I'm going to go ahead and find the determinant for D first. That's going to be negative 4 minus a negative 6, right? Negative 4 minus a negative 6 would be plus 6. So I'm going to get a determinant of 2. So my D inverse is going to be 1 over that determinant, right? Now I'm going to switch the A and the D. So I switch and put a negative 2 here and a regular 2 here. Right? Switch their spots. And I'm going to change the sign on B and C. So this is going to become a negative 1, and this is going to become a positive 6. When I distribute the 1/2 through, I get negative 1, 3, negative 1/2, 1. And that's my D inverse. Okay? All right, so that's it for finding the inverse by hand. There's extra practice at it. There are problems in your textbook where they actually show you how to find the determinant of a 3 by 3 matrix, and I might tack that on here at some point for some fun, but you do not have to memorize the determinant or the inverse for anything larger than a 2 by 2 matrix. All right, so let's do some cryptography. Okay, so when you're doing cryptography, the first thing you want to do is make a concise message. So I'm going to use math is awesome. Right? And again, what we're doing here is we're encoding with matrices. So to encode your message into numbers, you're going to use an alphanumeric code similar to the one that's on this lovely table that was at the start of the section. This is the standard one. If you were going to use something else, you would agree on it with the other people that you were communicating with, because the general assumption is that A is 1 and B is 2 and so on. Okay, so first thing I'm going to do is encode this. So I look for M. M is a 13, right? And I tend to put little lines between my numbers so that I don't get confused, because I am easily confused by life in general. But you can see how that kind of gets you in a pinch where you don't have a lot of room to write. So it's up to you. I tend to put little lines between them. So I get a 13. A is 1. T is 20. H is 8. Spaces are 0. Right? So that was an 8, sorry. I is a 9. S should be a 19. Space is 0, A is 1, W is 23, E is 5, S is 19, we already saw that, O should be 15, I think. Yep, O is 15, M was 13, and E was 5. Okay, so first thing I do is I make it a list of numbers, right? So it's a list of numbers. You could also separate them by commas. I always just use lines to separate them, but it doesn't really matter. Now, some people might argue that that message is actually encoded, and it is encoded. But not very well, and anybody that wanted to crack it would be able to do it pretty easily by assuming that, numerically A is 1 and so on. And even if you didn't use that, there are ways to crack a code where the numbers are assigned differently by looking for the frequency of numbers based on how frequently letters occur in the English language. For instance, E occurs more than any other letter in English. So, okay, so that's the first thing I do. The second thing I'm going to do is I'm going to write my message as a 2 by blank matrix, okay? So the reason we're going to do this is we're going to use a 2 by 2 encoder. You could use a 3 by 3 encoder or a 4 by 4 encoder. You could use any square matrix as an encoder, but since it's really annoying to have really big encoder matrices and ugly inverses, it's much easier to pick a 2 by 2 encoder matrix. So we're going to pick a 2 by blank matrix. Now what that means is I have to count how many characters I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I currently have 15 characters, and that does count the spaces because they are characters in my expression, right? So 15 characters. So what I'm going to do is I'm going to tack a space on at the end and call it that space 0, right? So I'm going to use 16 characters by tacking a space on at the end. And what I'm going to do is I'm going to go straight across and I'm going to make a matrix into this. So it's 2, so I've used a 2 by 8, right? So 2 by 8, that's not the number 8, for my 16 characters. And I go straight across, see 1, 2, 3, 4, 5, 6, 7, 8. Those are my first row, 13, 1, 20, 8, 0, 9, 19, 0. And then my next row is the 1, 23, 5, 19, 15, 13, 5, 0, okay? Then I'm going to choose a 2 by 2 encoder matrix, right? So it really doesn't matter which one you choose. I'm going to call that E, right? But what I will say about your 2 by 2 encoder matrix, and this is super key, you really want to choose something that has a determinant of 1, right? So by determinant of 1, I mean that if you do AD minus BC, you get a 1. It makes it much, much easier. So when I say determinant of 1, that's what I'm saying. So notice that this is 4 minus a 3. Why is that easier? Because it means that I'm not going to get fractions and decimals in the message that I'm going to hand to my friend. Because if I hand my friend a message with rounded decimals, right, like a repeating decimal that I round, then my friend's not actually going to be able to reverse engineer my message. I need happy integer values in my matrix. So in order to make sure that I have happy integer values in my matrix, I'm going to pick a matrix with a determinant of 1, which I did. So this is my encoder matrix that I'm going to call E, okay? So what you're going to do in your calculator is you're going to type E. So this was my E and this was my message M. Because I have a 2 by 2 and a 2 by 8, I have to multiply them in the order EM because E is 2 by 2 and M is 2 by 8. If I tried to multiply them in the other order, they wouldn't multiply. So I do E times N, and the result is a 2 by 8 matrix that is my secret. And I'm going to call it S for secret. Okay, so that's my secret message that I'm going to call S for secret, okay? Sorry, didn't mean to accidentally make this be larger than the window I had. So once I have this encoded, I'm then going to take it out of matrix form the same way that I put it into matrix form and make it a list for my friend. So this is the secret that I hand on a slip of paper right? So this is my secret message. Now my friend is going to need a couple things, right? I write this string of numbers. My friend's going to need the secret message. My friend's going to need to know the encoder matrix, or I could just tell my friend what the decoder is, right? But that seems silly because then I'm sort of handing someone the answer. So I give someone the encoder matrix. Okay, so that's the idea. We have this encoded message. What we're going to do is we're going to walk through how to decode a message, and then we'll do some examples. But that's the way you would encode this message. So you have a weird cryptic message from your friend, right? So your friend did you this weird cryptic message. Hang on, I would like to, let's see what 100% gives us. That's slightly better. Let's see where that puts us. Much better. Okay, so you have this weird cryptic message from your friend. How do you decode it? So your friend hands you this slip of paper. First thing you need to know is you need to know the encoder matrix, right, which we called E. So your friend has to give you your encoder matrix. Now, you might say if someone's giving me this matrix, then they've given up the whole code to someone. But if you really wanted to be creative, I'm sure that you could find, like, if you were actually giving secret messages this way and they were actually super important, I'm sure you could find some clever way to describe your encoder matrix in a way that does not just give up the numbers, but who knows. Anyway, so they have this secret and they have this encoder. Basically, and they also need to know the alphanumeric code that you used, but the general assumption is that A is 1 and B is 2. So unless you used a different encoder matrix and a different alphanumeric code, you can pretty much assume that's what it is. So then you're just going to do the reverse steps, right? The person's going to write this as a 2 by whatever matrix, right? They're going to count and they're going to realize that there are 16 characters, right? So they're going to recognize that that's got to be a 2 by 8. So they're probably going to count 1, 2, 3, 4, 5, 6, 7, 8 and realize that's the cutoff, and then they're going to enter this into their calculator, right? So ignore that there was something in the calculator before, because so we're going to go ahead and go to second matrix, right? And I'm going to go to edit. I'm going to pick A. Now, A is going to be 2 by 8, and one of the reasons I want to enter this in front of you is I want you to see that that's not fun because I can't see all 8 entries. So I'm going to have a 29, right? A 71, a 55, a 73, a 45, a 57, a 53, and a 0, right? And that's my whole top row. I go to the second row, and it's going to be a 15, and a 47, and a 30, and a 46, and a 30 again. Let's move this guy over, and a 35, and a 29, and I'm hoping that I land at a 0. Perfect, so it's all full. Cool, so I get my matrix in as A, right? So I put this thing in as A, right? This matrix S, that was my secret matrix, I put it in as A, right? So I write it as a 2 by whatever matrix, and I called it S for secret. So I put it as A in my calculator, but that's my secret message, right? Matrix S. So because E was the thing that encoded the message, in order to decode it, I need E inverse. So I put this in. I'm going to put B as what the encoder is in my calculator. So I'm going to quit out, second quit. I'm going to go back to matrix, right? I'm going to go over to edit. I'm going to pick B, right? And I want it to be a 2 by 2. And I don't have to find I don't have to write the decoder by hand because I understand that I'm going to use my calculator's inverse function to do that for me. So I put that in and I second quit out. Sorry, ignore the alpha. There we go, second quit. Okay, so now I want E inverse. So I'm going to go second matrix. I'm going to pick B, which was the E for me, right? I chose not to use E and S because it was a little bit difficult. It's not worth scrolling that far down. I'm going to go to second matrix and I'm going to pick A, right? So that's my E inverse times S, right? I mean, actually, I used B and A, but you get the idea. And I'm going to get an answer. So the trick here, and you don't have to do this. Actually, let me scroll this over for a sec so that we can. Okay, so the trick here is that it's really tedious to have to scroll all the way over. So what I would suggest that you do is I would suggest that you write it in pairs, even though that's not how we read a matrix, because otherwise you're going to have to scroll back and forth a bunch of times and it just doesn't really feel like it's worth it. I did not give myself enough space. Hang on. Let's give ourselves a little more space. Okay. So if I were you, I would, even though this is not how you read a matrix straight across, I would do it this way so that you don't have to scroll over a bunch of times, right? So I would just, This is not how we read a matrix, right? If we read a matrix, we read it left to right and then next row, right? So 0, 15, that's a 0. It kind of made it look like a 6. 9 and 13, 19 and 5, 0 and 0, right? So one thing to note here, if you end up with numbers in here that are negative numbers or decimals or fractions, something went wrong, right? So once I do that, right, now, and again, you're using a calculator to do this, nobody expects you to do it by hand. Now you're going to go ahead and use that alphanumeric table, right? Now you can write this out as a string of numbers. If you want, you can skip this step, right? This is definitely skippable, right? I don't know if there's another P in skippable. I don't even know if skippable is a word, but you get the idea. Because you could just write the letters right above your matrix, right? You could figure out that this is math space is space awesome space, right? And there's your answer, right? So cool. So let's go on to the next one. Okay, so your textbook actually has in example 5, they ask you to use A inverse to decode this message, right? So you'll notice that these are not numbers with the exception of 10 and 12 that would show up on this table, right? This is 1, 2, 3, 4, 5, 6, right? There's 6 characters, so you want a 2 by 3, right? So it's up to you. I'm probably going to go ahead and call this B in my calculator because I already have A as a 2 by something in my calculator. So what I'm going to do is I'm going to go ahead and put this in as A in my calculator, 52, 165, 10, 61, 195, 12, right? And I'm going to go ahead and put this in as B in my calculator, and then I'm going to do B inverse times A, right? So when I put this in my calculator, I'm going to go to second matrix, rather, right? I'm going to go to edit. I'm going to make this a 2 by 3, which is a nice relief after 2 by 8. 52, 165, 10, 61, 195, and 12, right? Double check that all those numbers are the right numbers. They seem to be. Quit out, and then I'm going to go to second matrix. I go over to edit, and I'm going to pick B, and I'm going to make B that 2 by 2, 6, 5, 7, and 6, right? Double check that your math is right. Cool, you entered everything right, and then I'm just going to hit enter because I already did B inverse times A. So when I do that, right, I'm going to get these values, right? And again, you could, if you wanted, write them out as a string. So you could say, oh, I get it at 7, 15, 0, 2, 15, 2, right? And that's great. And then you could also probably write the letters right above the matrix and figure it out, right? So I go over here. 7 is G, right? 15 is O, right? My 0 is a blank. 2 is B. 15 was O, and 2. So hey, go Bob! Yay, Bob! Yay, Bob! I don't know who Bob is, but congrats! Good job, man! Yay, Bob! All right, cool. So let's go ahead and have you do one as well. Here's the encoder, right? And you're going to decode the message. Again, if I were you, I'd call this B just because I'm lazy and I've already been encoding and decoding stuff in my calculator. And I would go ahead and put this in as A as a 2 by blank 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's got 10, so it'd be 2 by 5, right? So it's up to you, right? I would call this A, I'd call this B, and then I would do B inverse times A, right? But again, up to you, right? So second matrix, I'm going to go over to edit. I'm going to make a 2 by 5, right? I'm going to do 97, 70, 68, 80, 24, and that should be the end of that row. And then 62, 45, 45 again, 52, and 16. And I double check that they're all right? So I have a 16. So one easy way to check is that you can actually kind of put the line there and recognize that 16 and 24 should be the last column, and 80 and 52 should be right before that, and 68 and 45 should be before that, and yeah, they look good. Okay, so I'm going to quit out. I'm going to go back to matrix, right? I'm going to go to edit. I'm going to pick B. Oh, sorry, my bad. Accidentally slipped and hit clear. Edit. I want to pick B, and I accidentally picked A. Just ignore me. There we go. All right, cool. So my B is still a 2 by 2, but it's going to be 5, 3, 3, 2. And you'll notice that all of these matrices that they picked as the encoders have a nice happy determinant of 1 because, again, it's a good idea. So here's my answer, right? And again, here you can actually see all the numbers. The dot, dot, dot is just because you can't see the end of it. But in reality, the 0 and 8 are the end. It's not like that's a 0 and an 80 or something, right? So that's actually the end of your matrix, right? So that's it. And again, if you want to write it out, you can. If you want to write it as 8, 5, 1, 4, 0, 19, 15, 21, 20, and 8, you can. If you want to just write the words above and then write the full sentence, that's also okay too, right? So 8 is H, E is 5, A, head, space, S, O. I'm going to guess we're going for south. Yep, head south. So there you go. Cool. So I think our next, this is the end of our actual practice of stuff. The next video is just some cool stuff about cryptography and some of the things that have happened in the history of the world in terms of countries and armies and other people trying to use certain by-hand devices to encrypt their messages, which is kind of cool. So that's about it. I think that's the end of this particular, yep, that's the end of this one.